Hi everyone, and welcome to our video on finding the slope of a line. So the slope is designated as m in math, mostly because s looks too much like 5, so we use m to show what the slope will be. And maybe not the most mathematical definition, but it tells us how steep a line is. And it can be positive or negative. So for instance, like I'm just drawing a random line in. So here's our random line, and maybe the slope has a slope of 5/2. Okay, so we usually have it in fraction form, but it could be a decimal or a whole number. You can have, let's draw just another random line. So this one's not as steep, so it's kind of more horizontal, which means it's going to be closer to 0. Okay, however, it is going up from left to right. So positive slope means the line goes up from left to right. Let's just add that right there. Just like reading a book, so it's always read from left to right. Okay, so there's a couple of just positive slopes, and you can have a negative slope, which a negative slope tells us that the line, let's put this first, the line goes down from left to right. So again, reading it just like a book, from left to right, the line must go down. So for instance, maybe here's a random line. Now this is pretty steep, which means the magnitude of the slope. So we know it's negative, and then the magnitude is just the number part without the sign. It's going to be larger, so it would be negative, and let's pretend that this is like -8. Okay, and we'll actually know these exact numbers when we start to do real graphs and real lines, but here I was just kind of showing what some of them might represent numerically abstractly, just in open space. So for instance, let's get one other. Say we've got another one that's going down from left to right. This one again is kind of more horizontal, but we know it's negative because it's going down from left to right. And let's go ahead and just say that this one is 0.75, -0.75, just to show it could still be a decimal. However, a lot of the times we would prefer it to be in fraction form. Okay, so there's our visuals of the slope, and let's add the one thing that I was saying. Okay, so the closer, or let's say the more horizontal a line is, the closer the slope is to 0. Okay, so like both cases are positive slope. The one that's more horizontal, this 1/3, is closer to 0. Same deal with the negative. The -3/4 is closer to 0. It's more horizontal. Okay, so there's some visualizations. Okay, so but to find the slope through 2 points, so most of the time we'll know at least 2 points. And what we'll have, let's go ahead and just draw. Here's our XY axis, and I'm just going to put a point here and a point here, and we'll connect them with a line. Well, the best that I can with my computer pen. And what we've got, so there's different ways to interpret the slope. In words, we often say it's the rise over the run, which is by making a right triangle with our line, keeping the line part as the hypotenuse. And this vertical length we often say is the rise. This horizontal length is often the run. So like if you're running on a treadmill or on the street, preferably we're running on a flat surface. And then if you're rising, you're going up, or like the sun rises, it goes up into the sky. Okay, so we're kind of using that vocabulary. And what we can do in words is say that our slope is the rise over the run. Oop, there we go. However, again, that's not the most mathematical way to break it down. Let's go ahead and label some points. So for instance, this one on the left, let's go ahead and call it x1, y1. So we're just using a point. That's our first x coordinate. That's our first y coordinate. And then our second point, let's use x2 and y2 to show our second x coordinate and our second y coordinate. Well, our run, the run and the rise, each of these are just lengths that we can measure. So the length of the run, let's start with that, is the difference between x1 and x2. So it's to get this length, we can say the run is, and typically we'll start with the x2, but the order really won't matter. Let's go ahead and say it like that. So the run length is x2 minus x1. And then the the rise, we can do a similar thing where we can measure this vertical length, which would be the difference of our two y coordinates. So let's just put it right here. Our rise is y2 minus y1. And then that way we can put it into the formula. Our rise is the same thing as y2 minus y1. Our run is the same thing as x2 minus x1. Now, with fractions, they don't usually show it, but these would have implied parentheses. So in case we need to make sure we're doing the correct order of operations, we would want to simplify the entire numerator and then the entire denominator and then divide. All right, so let's break it down. So let's see how we could do some of these problems. So if it says find the slope, we can do rise over run, or we could do the equation. And let's break it down both ways here. So for instance, in this picture, they do also want us to find the x and y intercepts. However, I'm going to find the slope first, which I'm going to mark in blue. Okay, so what we need is a couple of points here that are easy to look at. Well, I'm going to use those x and y intercepts, even though I'm doing them second, because it looks like I can see the line is definitely going through those grid marks. And so all I got to do is measure this length right here and this length right here. And then that is our run, and that is our rise. So our run, we can just count. It runs 1, 2. So it has a length of 2. And then it rises from 0 to 3 is, 1, 2, 3. So we can just count this one. And then we can also make a note, because the line is going up from left to right, we do know that it has a positive slope. And then putting our rise and run and the positive slope together, we're just going to say, let me go ahead and put it in words still for now, and then let's put m is equal to. So our rise is 3, our run is 2. It should be positive because it's going up from left to right, so there it is, it's all done. Okay, the other way to have done this problem is to use the equation. Actually, let's still call it number 1. So the equation would be doing y2 minus y1 over x2 minus x1. And we just have to actually label those points. Well, we've got I'm going to label this first point as negative 2, 0. So that's our x1, y1. And then up here is the 0, 3. So that is our x2, y2. And then from there, we could plug it all in. So our y2 is, let's get the fraction. So our y2 is 3. Now let's go ahead and use parentheses to show our substitution. Minus y1, which is 0. And then x2 is 0. Minus x1, which is negative 2. And then using the order of operations, simplifying the whole top, 3 minus 0 is 3. 0 minus negative, so you have a minus and a negative, so that would become positive 2. And so mathematically it works out and gives us the same value, as it always should. Okay, so that's how we could break down the slope. And then, well, part 2, finding the x and y intercepts. I'm just going to mark it 2 kind of above. Well, I already wrote them on the grid. So the x-intercept, as a reminder, the x-intercept is a point that's on the x-axis. And our point that's on the x-axis is negative 2 and 0. And the y-intercept would be a point that's on the y-axis. And so that point is 0, 3. Okay, and they typically want it in points form. Now, sometimes the notation, they might just say, just list the x value, so just negative 2. However, I'm going to leave it as a point because I think that's kind of better notation. Okay, so that's how we could find the slope with given a graph. Now let's go ahead and find the slope given some points. So it's the same deal with what we just did. I would always sketch it first. So let's draw a picture. 2, 3, so 1, 2, and then up 3. So there's that point. And then negative 8 and 5. So 1, 2, 3, 4, 5, 6, 7, 8. And then up 5. So 1, 2, 3, 4, 5. Right there. And then from there, we could draw it in. Now, I drew my picture kind of small. Sometimes it's not a good idea to do small pictures, but I think it's okay in this video. All right, so we've got our points. And there, let me just go ahead and continue to label. There's the points. There we go. Okay, so again, we could with integers like these, so there's no decimal or fraction. It's often just as easy to do the rise and run with the picture. So for instance, especially if it's on a very nice grid, we can just count. Now again, my picture I kind of squeezed into the side here, but if I am going to count like the run, so currently I'm over 8 to the left, so 8 would get me back to the axis, and then another 2 more would get me to this point. So I'm going to mark that as 10. So that is counting, so 8 to get there, and then another 2 to get there. And then from 3 to 5, well, 3, 4, 5, it looks like that's a length of 2. And so there's our rise and run numerically. Let's go ahead and keep it in purple. So doing the rise over the run, I've got the rise is 2 and the run is 10. Now, if we're doing it this way, though, we don't want to go too fast. We do want to make sure, hey, this line is going down from left to right, so it is a negative slope. And so that just means, well, just put a negative in with the number. And then, well, if you can reduce this, do that. So 2 over 10 reduces to 1/5. Okay, so that's our slope using the rise over run, just looking at the picture. Now, if I'm going to use the formula, well, again, I could just mark these. I would still draw the picture no matter what to make sure the sign is going to be correct in case our math goes wrong. But I am going to mark these, and we'll just use our equation this time. So the slope is y2 minus y1 over x2 minus x1. And then we'll plug those in. So we've got 5 minus y1, which is 3, over x2, which is negative 8, minus x1, which is 2. And again, I like to use the parentheses to show my substitution, but from here it's now order of operations. 5 minus 3 is 2. Negative 8 minus 2 would be negative 10. Now, typically we don't like to leave a negative in the bottom of a fraction like this when it is just a number over a number. We typically either bring it to the top or to the very front, and then afterwards reduce the fraction. And so again, we get the same number. Okay, so that's how we could break these down. All right, so let's take a look at this other one with some decimals. Right away, let me go ahead and label x1, y1, x2, y2. And with this, let me again draw a picture. Negative 1.5 and negative 4. So here you don't even need to do the tick marks every time. I'm just going to do it where I'm in a blank space and just make sure it's in the correct quadrant. So there's that point. And then 4 and negative 2. So 4 to the right and then down 2 would be something like that. So we could see that it's going up. So it should be a positive slope. But on this problem, because they gave me a decimal, I'm going to go straight to the formula from here instead of trying to count. So it's not that easy, or it doesn't work as well when you start to get decimals and fractions to count like we did on the previous problems. So let's go ahead and set up our equation. There we go. And then let's now plug in our values. So we have y2 is negative 2 minus y1, which is negative 4, over x2, which is 4, minus x1, which is negative 1.5. Okay, and then now we just need to simplify. Well, be careful of the double negatives. Okay, so we've got, let's simplify. Let's just do for now. So we have negative 2. So I'm just rewriting that without the parentheses. And our next term, we have a negative and a minus, so that would become plus, so plus 4. And then a similar thing happens down below. 4 and 1 point, well, it would be 4 plus 1.5. And then now we'd want to simplify what we can. Okay, so we've got positive 2 up top. And then we would have 5.5 down below. Now, if they give us a decimal, chances are we can leave our answer in the form of a decimal. And so the way that I'm going to do that, I'm just going to use the calculator on the computer just real quick, just to show, oh, well, 2 divided by 5.5 is this 0.3636 repeated. Okay, so the repeating isn't as ideal as what we would want it to be, but it might still be an option for us. So let's go ahead and just put this to the side, 3, 6, and I'm just going to put the repeating symbol over it like that. Okay, the other way to have dealt with this is to change these into fractions. So for instance, the 2 is 2 over 1, and then divided by, so 5.5, well, 0.5 is nice enough where we can convert it. So let's just do a little scratch work. So 5.5 is the same thing as 5 1/2. And then from there, we could use fractions to multiply 2 and 5 is 10, plus 1 is 11. So it's the same as 11 over 2. Okay, so I'm just converting the decimal into a fraction. Now, because 0.5 is a nice enough number where we could do this without too much effort, this is where we might be able to change it to a fraction, just like this, just fine. Now, if some crazy decimal, like say 5.173, then chances are they wouldn't want to make it into a fraction anymore. Okay, but just to continue showing what we can do with this problem, so we can do, to simplify, this division bar is the same as the division symbol, so it is 2 over 1 divided by 11 over 2. And then from there, we could do keep, change, flip. So keep the first fraction, change the division into multiplication, and then flip the second fraction. And then now we can multiply straight across. 2 times 2 is 4. 1 times 11 is 11. So that would be the slope in the form of a fraction. And we could always check 4 divided by 11 is the same thing as what we just got. Okay, so, and then also many calculators can convert decimals to fractions. And I think I have some stuff later that would show that. For now, I'm just going to leave it as 4 over 11 or the 0.36 repeated. So they are both correct. Okay, so that's how we can find the slope given 2 points. So we can do our picture, and notice back to our picture, positive slope, our answer is positive. So it looks like we didn't make any mistake with the arithmetic. Okay, one other type of case where we can find the slope. So instead of given 2 points, they might give us an equation. And so the equation of a line has different forms. Right now, this is called the slope-intercept form when they do y equals mx plus b, where m is still the slope, and then 0b would be the y-intercept. Okay, however, to do these problems, all they want us to do is find the slope. All I got to do is look at what's attached to the x. So right here, currently there's just an x hanging out. Let me go ahead and rewrite it. Remember, if there's ever a blank space before the variable, it is 1 that's hanging out there with it. So it is 1x and then plus 7. And so to find the slope, all I got to do is look at that number right there. That is the slope. M is 1. Okay, so if they give it in the form of an equation, we just have to make sure it matches this form. And then from there, all we got to do is just state whatever number is attached to the x. Okay, so this one. This one, it doesn't have any plus or minus anything. Well, that's fine still. All I got to do is look at what's attached to the x, which is negative 7/3. And that's it. Done. Okay, if they don't give it to us exactly in this form, well, we can change it to be in that form. So I want to solve for y in this problem first. So to do that, we can subtract 12x to both sides. And I'm going to kind of squeeze it in between. So the 12x and the 9 do not combine in any way. They're not like terms. But I'm trying to squeeze it in between first to match the exact form of our slope-intercept form of a line. Okay, so this 8y just dropped down and then equals, and then let's put the negative 12x plus 9 on the right side. And then I want to solve for y means I need to get it all by itself. Well, to do that, in this case, I would divide everything by 8 in this step. And then now I can write y by itself. Negative 12 over 8 reduces. They're both divisible by 4. So it would be negative 3/2. And then x is still attached. And then plus 9/8. Now that it's in the form, all I have to do is look at what's attached to the x, which is the negative 3/2. And that's our slope. Okay, and then later on we'll graph these and verify and show that we have the correct slope with a picture. But let's get one more in here. All right, so again, it's not in the exact form. So on this problem, we need to solve for y also. So our very first step then looks like I should subtract 2 to both sides. This time I do have a like term on the right side with it, so I can combine those. So it looks like we have negative 3/4 y equals 5 minus 2 is 3, and then minus 24x. Okay, so, and make sure to keep the sign that was with the y, so this just drops down, so does that. So the things that don't have like terms just drop down with it, with their respective signs. Okay, this time around I have a fraction though with the y. Well, instead of divide, so you could divide by negative 3/4. I'm going to erase this. So you could do this to every term. However, it's not as easy to work with. So instead, whenever you have a fraction, instead of dividing, we'll do what's called multiplying by the reciprocal. Okay, so I want to get y completely by itself. So I'm going to multiply everything by the reciprocal of what's attached to the y. And this does multiply all parts. And then when it does multiply, so the reason that we do this is because this 4 and that 4 cancel, and the 3 and 3 cancel, and so do the negatives. The negatives become positive, so that becomes just y. But we need to make sure we do it to all of them. So let's go ahead and show this as negative 4/3 times 3 over 1. Remember, you can always make any number of fraction by putting 1 under it. And then minus, let's put the negative 4/3, and then the 24x over 1 like that. Okay, so I just went ahead and canceled the very first term to get just y. And then over here, I just need to do some simplifying. Well, when you have fractions, you can multiply straight across, or you could divide first if there is something that is common. So for instance, 3 and 3 in this part just divide, and I'd be left with negative 4 over 1. And then from here, we'll change that in the next step. And then on our second term to the right of the equal sign, I do have a minus and a negative, so that would become positive. Okay, so let me just go ahead and highlight that. So those become positive. And then now all I really have to do is simplify the number parts. Well, just like the last step, I can divide first instead of multiplying. So 24 divided by 3 is 8. So really this simplifies to be 4 times 8, and then x is still just attached. And so now let's simplify one last time. We have negative 4 plus 32x. Now this currently isn't in the exact form. However, you could say, well, the number that's attached to the x is still the slope. If I do want to make sure it's in the exact form of our slope-intercept form of a line, I can rearrange these. Again, just make sure their signs are still correct. So the 32 is positive, and we usually don't show the little plus on the first term, but I'm going to do a real small one. So it is positive 32x, and then minus 4 is second. And so there we go. That's our slope, the 32. It's the value that's attached to the x. Okay, so that's how we could break down these problems. Okay, so these are the different ways to find the slope given the different scenarios that we have. All right, so if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.